Welcome back to Automation Developer Days. This is our second day of the virtual event. If you did not join yesterday, my name is Niklas Wägert and I lead the automation developer community. I will be your host today and I will just give you a short recap of yesterday. So yesterday we focused on NSO. Our technical deep dives touched on performance, all the things that we have done over the recent releases to improve performance. We also talked about robustness, the capabilities in high availability that we have been adding. You could also hear Roque talk about container orchestration. He talked about everything where we started, from orchestrating physical devices to virtual network functions to containers and best practices around that. A really good presentation. You could also hear Scott Barwick from Datadactus talk about robot test framework. He talked about the best practices and then the lessons learned, how they have derived more value from using that, more than just detecting software errors. Also a good presentation. But I was very proud to have the CX team, Soumya and Koen, talk about sustainability. It's a super important topic that we will come back to. After the session, we had a brainstorm workshop, and I'm so excited to see the readout of that. And we will, of course, share that with you on the community. So if you missed anything, just go back to the event hub, check the recording. Eventually, you will find them on YouTube as well. So I just want to reiterate a little bit about what a hybrid event is and what it means to us. So we have a live event in Stockholm and we have the virtual event for you. Our main goal here is to create an inclusive event for all. You should be able to decide if you want to come to Stockholm or if you join the virtual event. We want you to get a similar event experience. We know we can't do that because we have to be respectful of your time. So for the virtual segment, we keep the sessions shorter, typically 20 minutes. The days are shorter, typically 2 hours compared to 8. We also do 2 days instead of 3. But everything we do in Stockholm will be recorded. You can find it on the event hub or our YouTube channel. So you won't miss any important information. We also have the workshops. And these are real hybrid workshops. We have in-person attendees collaborating with you guys remotely. If you have signed up to those, I look forward to meet you again this afternoon. So what can you expect from day 2? Well, we have a packed agenda today. And if we focus on NSO yesterday, we will focus on the platform, on the network automation suite today. We will focus on getting more insights or visibility to get better insights to drive actions. Today, we will begin with Accidian, who will talk about the network assurance solution that they have integrated together with us in Crossworks. You will hear from our technical marketing engineers that will talk about monitoring devices and monitoring services in Crossworks. And we will round off the day with our Crossworks Cloud presentation on how you can optimize your BGP peering traffic using Crossworks Cloud. So we have a fantastic day ahead of us. But before I hand over to the technical sessions, I have asked Jared Headley, he's a Senior Director of Product Management Team, to double click on our strategy and to help you understand where we're at and where we are going. So with that, I'd like to hand over to you, Jared.
Thanks, Niklas. It's great to be here today with you all. I'm grateful for the opportunity to talk with you. My name's Jared Headley, as Niklas talked about, and really excited to focus first on picking up where Kevin left off yesterday. Kevin talked a little about our automation vision, right? Driving visibility, insights, and action to really bring together this closed loop, fully autonomous vision that we have. At the end of the day, We want to absolutely enable our customers to have the experience of being able to truly automate the network in a way that allows them to gain the visibility into the network that they need, to correlate that into insights that are actionable and useful, that allow them to plan the network better, to allow them to design the network better, to allow them to implement things, and do this in a fully automated fashion. Now, are we there yet? The answer is no, we're not. But that is our vision and that we're driving to. So now if you take a step back and you think about the last day of developer days, and you think about, well, this was very NSO centric, and having been with the NSO team for a long time, this is absolutely what we meant to have, right? This NSO, rich NSO environment that gives you a layer of API that now you can develop on top of, right? Making basically software API in the network and developing on top of. So where do we go from there? What's the bridge that we build? Yes, I know, sorry for the pun, the Cisco pun. But the bridge that we build is now that same experience that you have with NSO, where we want to drive a rich developer experience and allow you to have a community that you can work with as you build applications and services on top of it. We want to drive that into Crosswork. So as we drive that experience into Crosswork, what do we need to do? Well, the first thing that we're focused on is, yes, a lot of customers ask us for, hey, I want the single pane of glass across the entire Crosswork experience. We know in reality, that's often not going to happen at our customers. We could build that across every Crosswork application, and yet we know that customers still have a whole bunch of other applications and technology that they have in place. And so as a developer, what we're focused on is, well, we want you to take advantage of all the visualization capabilities that we're building into Crosswork, something we didn't do on the NSO side, right? These rich visualization capabilities. We want you to be able to take advantage of having an open set of APIs into that now to bring up a higher level set of applications, to build in across the federation of applications that our customers will run to truly automate the network. So let me give you an example to make this concrete, right? NSO, I would often use to do an application and build on top of it and build all the capabilities I need, including visualization, including workflow, and including a number of other things, and then take advantage of the powerful orchestration engine that NSO gives you. On the Crosswork side, now because I have visualization built in and capabilities, the question is, where does the developer opportunity to help solve problems? Well, we drive up a higher layer for the customer. So think about 5G networks and the promise of 5G slicing, the ability to allow enterprise customers to provision slices across the entire network. But it's not just about provisioning the slice, it's about then driving the partitioning actually down into the network. And so using these standard IETF APIs that are getting finalized right now, right, Cisco wants to play the role of being those transport domain controllers with Crosswork Network Controller and Crosswork HCO. We want to allow customers to have that single experience across their IP and optical networks to provision out the capabilities needed for the 5G slice. But on the other side is allow them to talk northbound to cross-domain systems, whether that's a traditional BSS OSS system or Cloud Pak for automation from our friends at IBM, or whatever technology it is above them, bringing that slice together. Now, as a developer, we want the experience to be in the next year or so for you to be able to take the rich APIs that we've done that talk to these individual domain controllers and bring them together to create a rich experience on the cross domain. The opportunity to do enterprise management applications that allow the enterprise to work across the 5G slices, the ones that allow operators the right amount of integration into their BSS and OSS systems. And so that's where we see the next generation of opportunities. And that's why we want to talk to you today, throughout the sessions that you have today, about Crosswork and the direction that we're going, so that you as a developer can take the same great things that you've done on NSO and then apply them to this new environment that not only brings together on-premise set of technologies, but a whole rich set of cloud technologies that we're bringing in with our Crosswork Cloud offers, whether you're driving network insights or the ability to have trust embedded down into the device level, but being able to look at that across the entire network and potentially aggregate data across customers for more intelligence closed loop experiences that we want to drive into the future. Fundamentally, that's what we're trying to drive today as we bridge from NSO into Crosswork in this developer day experience. So I hope that makes sense to you. I hope that's an opportunity that you look forward to. And we hope that you enjoy the experience of learning more about Crosswork and how we want that to become another developer opportunity for you. So thanks so much. And with that, I'll throw it back to Nicholas.
Well, thank you, Jared. Well explained. I just love how you articulate that and how you paint the vision for our developers. We surely can save a lot of work for developers by providing these APIs on a higher level abstraction level. So before handing over to the technical presenters, I just want to reiterate, engage with us and ask questions on the Q&A and answer the poll sessions. We'll love your feedback. And with that, I hand over to Henrik Nudell from Acxidian. He will talk about the Acxidian Skylight product integration with Crosswork. Take it away, Henrik.
Thank you, Niklas. I'm Henrik Nudell, Product Manager at Acxidian Networks, and I'm going to talk about automation of network and service assurance today. So what is the Acxidian Skylight portfolio? So Skylight is a set of functions, a framework for bringing visibility of performance into your network, looking at both the infrastructure service layer, and it's built out of 3 different distinct tiers. So at the bottom, we have the sensors, the Skylight sensors. So you see a couple of them shown there. I'm going to focus mostly today on the agent type, which is the containerized test functions, but we'll also have other types of sensors. In the layer above, we have the orchestration tier, and this is where you control and set up the tests and define what will be done with the test results and how long you should test and those types of things. And then on the top layer, we have the Skylight Performance Analytics layer. And this is where all the magic happens with the metrics results. We can do correlation of data. We can do integration of third-party metric streams like telemetry and so on, and bring it all together as a comprised view of how well your network is and services are performing. So let's zoom in on the sensor layer to begin with. So in the Skylight sensor layer, as I mentioned, we have a couple of different types of sensors. So we typically refer to them as CNFs, VNFs, and PNFs. So the CNF is our containerized test agent, which is deployed as a software-only container. The VNF is a virtual machine that you deploy as a standard VM in your VM infrastructure. And the PNF is a pluggable piece of hardware that we have integrated our own FPGA into, which can be used in situations where you do not have possibility to install software. You can then plug our pluggable hardware module in there. The example shown here is the SFP compute, which is an SFP module, of course, so an optical device that runs at 1 gig or 10 gig, but can be plugged in any SFP port in a networking device and then bring Skylight visibility to that location. So regardless of which form of instrumentation you pick or you choose for your application, they can all perform various types of tests. And they can test either towards another Skylight sensor or towards a standard reflector or to a third-party service. And what does this mean? So I'll dig into a little bit what these different categories mean. So when we are testing between 2 test agents or 2 Skylight sensors, we typically call this as a bookended test. So in this case, It is usually a transfer-based test. We can transfer X amount of traffic from location A to location B and monitor how long time it takes or what bandwidth you got. Or it could be a more continuous type delay, jitter, packet loss type monitoring, where you want to have an SLA of a path or a service. The second category of tests we refer to as reflected tests, and these are usually defined based upon some kind of standard. The most common standard would be the RFC 5357 TWAM, which is a layer 3 test protocol used to monitor delay, jitter, and packet loss. So with these types of tests, you have a Skylight agent or a Skylight sensor only at one end of the test. At the far end, you instead rely on enabling that reflection service in the router or in the switch or in the server that sits at that location. The third category of tests we call service type tests. And in these types of tests, you have some kind of service that sits at the far end. Typically, it could be an HTTP server or an FTP server, something that responds to messages and can reply to us with some data. So with these types of tests, we can, for example, provide a download speed indication from a certain web service and report that all the way up through the Skylight portfolio. So how do you then deploy these test agents? So the CNFs, as they are containers, they rely on a container environment, but they can be deployed in virtually any type of virtualized environment. So we have customers using them on servers, on Linux OSs, whether it's physical or virtual servers. You can also deploy them in an orchestrated Kubernetes environment, such as AKS or Google, but also Red Hat's OpenShift is an environment that has been reasonably common to deploy containers in. And also, quite interestingly, you can deploy these container agents on network devices or network components. So Cisco XR and XD has support for third-party applications, and also other vendors that you may have in your network may support installation of third-party containers. So I'm mentioning a few here. Cradlepoint is one that has an ARM processor capable of taking containers. We're also testing Versa Envelop Cloud right now during the spring. So when you deploy one of these CNF agents on your device, they will, of course, consume some kind of resource, but the footprint is quite small. It's just a couple of percent of a CPU core if you want to do continuous 24/7 type SLA monitoring. And if you want to do throughput testing, we can get all the way up to 10 gigabits per second with just a single CPU core. And memory and disk consumption is quite small as well, around 200 MBs of disk space and RAM. So one important aspect, and this also comes back to the deployment of the test agents, is that these are single purpose. So we follow the container and microservice manifests and architecture. So each agent has a single purpose. So if you want to do testing of throughput, you would then deploy the throughput agent. And you can then, once the test is finished, you can destroy the container and redeploy with a different agent that performs a different type of test. So we do this to minimize both the amount of processing that we use, but also the footprints in the network. So you only have the tests deployed that you are actually going to use. So I'm mentioning the agents that we have available right now on this slide here. At the bottom, you see SDK, and this is something we are working on at the moment. So we're working on this together with a couple of our key customers to develop a framework for them to deploy their own tests using the Skylight framework for automation of service testing. So the idea there is that if you have test applications yourself, you can then roll them into a Skylight agent through this SDK and deploy and control them through the Skylight framework, just as if it was an Acxidian agent provided by us. So this is something that we are going to launch a little bit later on this year, the SDK. So around automation, the key aspect of this presentation. So I've talked about that these containers can be orchestrated and controlled, and this is, of course, a key aspect of a monitoring solution these days. You need to be able to monitor, to automate every phase of the whole life cycle of service assurance and service testing. So starting with when you actually deploy the agent, so this can be automated, of course. Since it is a container, we can rely on the existing container orchestration mechanisms out there to deploy agents at the locations where they are needed. Agents intrinsically support an outbound phone home architecture, so agents are completely useless, you could say, when they do not have a controller sitting on top of them. So the agent, when it wakes up, knows nothing, but it performs a phone home towards the orchestration service where it can register itself and then get information on what type of test to perform, which destination to test to, and so on. So this deployment can be done quite easily straight off the internet by using Docker pull. So all our agents are publicly available on GCR, on the Google repository. So you can immediately install and get it running by just doing a Docker pull. Or you could, of course, orchestrate it through Kubernetes or similar types of container orchestration mechanisms. We're soon also gonna allow installation through Cisco's XR App Manager. So this is a feature within iOS XR that allows you to control third-party applications directly from the CLI. And this also gives you the possibility to use netconf yang to actually execute the package install and package activation of an agent like this. But if you're using something simple like Docker Compose, there is an example here on this slide on what you would need to provide. So basically, the agent only needs a couple of things to get started. It needs an ID, a name, the point of registration where it should dial home, and a secret or an authentication token to register. That's all. And once that is provided, it can start up and be ready for testing. So when the agent has registered with the orchestration service, circled in blue there, it is now ready to take actions. So you could either have already pre-provisioned what it should do when it wakes up, or you can trigger it through our open APIs. So you can list which agents you have registered, which have appeared, and you can then tie them together to define where to test from and where to test to. So here's an example of the JSON to trigger a test, to set up a throughput test, defining a name of the test, which agent that should perform it, where to test to, and duration, and so on. So you can define multiple tests for every agent. For throughput testing, you can define tens of thousands of tests if you want. But for throughput tests, you can only have one test running at any point in time, right? But you can have a large number of tests defined and then select which one to run. And this is, of course, also API driven. So you would signal through the open APIs which agent and which test to start. And it will then begin running and reporting the data. So once the agent is starting to report the data, this happens northbound to the blue circle at the top in the Skylight Performance Analytics layer. So we can then take this measurement data and correlate it with other types of streaming metrics or streaming telemetry, and or feed it to a third-party consumer of the metrics and any associated data. So on the analytics layer, you can, of course, also graph and visualize the metrics. But for the purpose of integration with Cisco, we are using mainly our data bus to feed the metrics into Cisco so that you will have a closed loop of the metrics. One advantage with the Skylight Analytics layer is that we perform data cleaning and data aggregation. So if you have multiple sources of data that are, for example, reporting at different intervals, we can then normalize that data and feed it to you in the chunks. If you want 5-minute buckets or 1-minute buckets or 10-second data, we can do that for you. There's also built-in aggregation, alerting in the analytics layer. So you can define thresholds for any of the metrics and get those alerts delivered on the message bus. So how does this look like when brought into Cisco CNC and NSO? So of course, Cisco CNC sits as sort of the brain in this closed loop circle. CNC can signal and control through our orchestration services which tests to add and perform, and also where this data is looped back through our Skylight Analytics layer back into CNC. At the bottom right, you see also the third-party data source, and we have the possibility to bring in Cisco telemetry, for example, into our data pipeline so that you can collate this data together with the Acxidian sensor data and get a very complete picture of how well your network performs. So let's take a look at how this connects into the Cisco NSO. So we have added Young models and the RESTConf interface to our orchestration layer to allow NSO to signal and control the creation of tests and starting, stopping, and so on, controlling the whole phase of testing with the sensor agents and sensor control. So the test provisioning can be done both on our VNF and PNFs, as I mentioned, and the CNF solution. So currently we support 2 different test types with Cisco NSO, RFC 5357 TWAMP and RFC 6349 TCP throughput testing. So we are going to add the other test types as well during the months to come, but these are the 2 that are available at the moment. On top of that, NSO can provision metadata into the Skylight solution. And metadata is important to be able to do correlation so that you can tag a certain measurement to a certain location or a certain device. And this gives us the ability to cross-reference tests and provide much richer metrics and results out of this. You can also define alerts and thresholds from NSO through the Young models so that you can set your SLA limits and get the alerts back into Cisco portfolio. So an example of what this could look like, which we've done with a customer at the moment, where Cisco CNC is sort of, again, the brain and the context keeper of the solution. So this is where information is kept about the service details, what links are out there and names and so on. So CNC knows which services it is deploying and setting up in the network. So in the example of a layer 3 VPN service, CNC has the context of that and can then provide through the Young models into Skylight that context so that we can set up a performance monitoring, for example, or a throughput test on the newly created layer 3 VPN service. So in this particular deployment, we're using a Kafka bus to communicate alerts back from the Skylight solution. And we're also using a third-party system, Vitria AIOps, to create a transaction system for the whole deployment. So please check back on May 12th, where we will have also a demonstration of an integration with Cisco NSO and Skylight. That's all for today. Thank you.
Well, thank you, Henrik. That was a great presentation. Also worth mentioning is that this integration does not only work with Crosswork, it also works natively with NSO. Tomorrow you will see a demo in Stockholm. It will be recorded, so if you're not there, you can go back to the event hub or finally on our YouTube channel to see it. With that, I'd like to hand over to Dimitris Vlasopoulos. He's a technical marketing engineer, and Dimitris will talk about how you can onboard devices and monitor devices in Crosswork Network Automation Suite. So with that, Dimitris, the stage is yours.
Welcome everyone. My name is Dimitris Vlasopoulos. I am a technical marketing engineer with Cisco's massive infrastructure group, focusing on automation solutions. In this session, you will see how using a simple NSO service and Cisco's Crossworks Health Insights, one can start monitoring network devices from the get-go throughout their entire service lifecycle. NSO has a proven record with customers for the enterprise and service provider domains with multiple installations worldwide. It stands as the best-in-class product for managing the lifecycle of network services in a repeatable and predictable manner. The NSO ecosystem is constantly evolving, providing integrations and solutions that help address modern network automation needs. With the NSO Core Function Pack, Cisco has productized content to address the needs of specific domains. Virtual network functions and software-defined networks are examples of such efforts. It has complemented workflow solutions that require a human-driven interactive experience to facilitate a use case, but still rely on NSO to deliver the network configurations. NSO has also been integrated with tooling solutions and products by Cisco, our partners, and third-party vendors. Finally, NSO is at the center of advanced network operations with the Crossworks Network Automation Suite. This view represents Cisco's approach to automating across the entire lifecycle of network infrastructures, and it shows how NSO is the bridge between planning, designing, operating, and optimizing network environments. During the planning and designing phases, regardless of whether it's a greenfield or a brownfield network, we can leverage a range of Cisco products that provide insights and analytics, aiding us in making a sound design decision. Equipped with this knowledge, we can effectively now use NSO to apply the needed configurations and changes across the infrastructure. Finally, for the constantly changing environments like our networks are, we must be able to continuously operate and optimize them. Cisco offers a number of products that are purpose-built to address such challenges. So how are my devices doing? Well, it all begins with establishing a view and understanding of devices and data points that are crucial to my network operations. The what to monitor is nothing new to us and could be summarized with these points. Availability. We need to be on the lookout for anything that can affect our device's reachability and availability. For that, we leverage system alerts, system logs that provide information on a device's status and connectivity. With configuration changes, we are looking out for any ad hoc modifications to our infrastructure that may impact our mode of operations. We also need to become aware of other dynamic changes, such as network convergence, traffic rerouting, etc., that could have an adverse effect. With performance, we are looking at key metrics, preferably in real time, that provide insights regarding our device's current health and status. These insights can help identify causes for the current disruptions or preempt future problems by recognizing emerging patterns. With NSO features such as transactional guarantees, one can be rest assured that the service, intent, and other NSO-driven configurations have been applied successfully to the infrastructure. We can also, at will, validate the network configurations are in place and adhered by the infrastructure by using compliance reporting, device checksums, etc. NSO, however, should not be used as a monitoring system, despite the fact that it can retrieve live status operational data. Such data should be used only to satisfy a service's intent. To formulate an understanding of our networks and devices' health, we need to establish a baseline. This is the result of gathering statistical data for a certain amount of time that is indicative of what we consider to be normal network or normal device behavior. We use this baseline to compare it to future data points. We must also define a cadence for data collection. It is important, though, that we don't overdo it. We don't want to hog the devices, we don't want to hog the networks. However, we don't want to miss out on any critical events. It is an exercise of fine-tuning. Now, identifying misbehaving devices, well, that becomes an obvious thing after the fact, but it is challenging, as you most likely need to correlate a number of different performance indicators to determine and explain a device's behavior. Dropping packets, memory depletion, processing overheads, how do all these come together? So although we know the why we need to monitor, and despite the fact that we also know approximately what to monitor for, the proliferation of new device form factors, along with elastic provisioning, new network management protocols, new and emerging technologies can become somewhat overwhelming. So to help bring all monitoring aspects together and keep our efforts to a minimum, we can leverage Cisco's Crosswords Health Insights. Health Insights is a product in the Crosswords Network Automation Suite that focuses on providing comprehensive monitoring solution. The Crosswords Suite is a collection of applications that allow one to control, optimize, troubleshoot, and remediate their network. It provides users with visual representations, allowing one to validate customer experience. Users have complete visibility into the device states and the network services and operations. By gathering statistical data using Health Insights, the Crosswords Suite can help identify issues and patterns and generate alerts on matters that need immediate attention. To take it a step further, Crosswords provides the change automation application that enables users to create automated intent-based actions to implement changes in the infrastructure that need to react to undesirable situations and conditions. So we've seen that Health Insights is part of the Crosswords Network Automation Suite. It leverages a time series database to record data in real time. The data is then correlated and analyzed. When Health Insights is used in conjunctions with change automation, it can trigger actionable events to remediate the issue at hand with no human intervention. Health Insights uses key performance indicators to measure and collect quantifiable data from a device using regular intervals. This cadence is defined within every KPI and refers to how often do we need to collect the metric. The solution allows for grouping several KPIs together into what we call KPI profiles to better address areas of interest or concern where a singular KPI usually is not enough to produce a meaningful result. The profiles are enabled on the infrastructure devices, at which point the Crosswords data collectors begin retrieving the KPI datasets at the desired cadence. Health Insights provides support for the most commonly used network monitoring protocols. It provides multi-vendor support for GNMI, adhering to the IETF, JSON, and proto modes. It provides support for open config models, and it also provides SNMP support when used with standards-based MEMS. A Health Insights option allows forwarding data to an external Kafka system. This allows for other external products that lack metrics collection capabilities to use the data sets collected by Crossworks. So how does Health Insights actually make data actionable? Well, it commences monitoring by enabling the KPI profile on a device. Health Insights has a built-in recommendation engine that can suggest KPIs based on the device type, simplifying the what we'd want to monitor. The KPI profiles are a collection of performance indicators that define the individual metrics the monitoring needs. The collection frequency is determined by the KPI cadence, and it varies based on the metric importance. For example, we want to sample more frequently for a CPU condition of a device that can indicate an immediate issue, rather than the file system for which we'd like to establish a long-term trend. The collected data is then correlated and analyzed. Based on the KPIs, thresholds, and alert settings, the alerts correlation engine will inform the user via the application dashboard of the relevant findings. If an automation action is associated with the KPI, change automation will begin remediating the situation. Based on the action's remediation steps, what is called in Crossworks a playbook, the needed configurations will be delivered to the infrastructure to address the issue. Let's take a look at some of the Crossworks dashboards. In the Crossworks Suite UI, users are met with a home dashboard that is representative of the applications currently being installed. This particular view is indicative of a deployment that includes the Health Insights and the change automation applications. The dashboard provides a summarized representation of devices, their states, a list of top KPIs that have been triggered, and an overall alert status, a summary. Visual aids are used throughout the interface to help users quickly identify whether it's current or potential issues. We will see this UI in more detail during our demo. This view represents the Health Insights Performance Alert dashboard, where users can interact with the interface to obtain detailed information on alerts and metrics for the enabled KPI profiles, along with a historic timeline to better understand behavior and patterns. Again, we will see this dashboard during the demo. Well, it's time for a demo. Now, before we jump into the demo, a few notes regarding the architecture and the demo flow. We obviously have an NSO system with a custom-built service. We also have a Crossworks Suite installation that includes Health Insights. So for this demonstration, we have registered a new device in NSO that has just been rolled out. The demo service then applies some needed configuration to the device since it is a brand new device. These configs are based on our demo's current topology and are representative of what we consider golden configs for our network. Upon successful delivery of these configurations, the NSO service will make an API request to Crossworks Health Insights. This will onboard the device and then commence monitoring it. Health Insights will first enable the KPI profiles requested by the NSO service, and then in turn, it will trigger the data collection process. We are now ready to jump into the demo, showcasing Network Services Orchestrator and Crossworks Health Insights working together.
We will begin our demo by first logging into the Crossworks Network Automation web user interface. This will bring us to the home dashboard, which displays generic information on all Crossworks installed applications. Here the user can get an overall view of the network devices, their condition through application widgets. The view is fully customizable and one can adjust widget locations and widget options where applicable, such as timeframes, to filter the widget output. The Performance Alert dashboard is the center of operations for health insights, giving users detailed information regarding KPIs and devices being monitored. An alerts history chart provides graphical views on collected alerts and when these were received. Just like with the main dashboard, the user can modify display options such as the timeframes and the severity of alerts. The user can also select viewing results by device or by KPI alerts, allowing them to focus on specific issues. The KPI menu displays the indicators that are currently available in the system and represent the variety of metrics users can use to start monitoring their devices. The KPIs are grouped into categories by domains of monitoring interest, such as quality of service or layer 3 routing. This helps users make a quick selection of metrics that matter to them most. The KPIs in Health Insights can be easily exported and imported for transferring between other systems. Users here have the option to link the key performance indicator with a playbook that can trigger an automated action for remediating an issue, such as a flapping interface, for example. Users also have the ability to create their own KPIs. The system is pre-populated with models supporting a variety of quantifiable metrics and can also be augmented with the addition of new ones. The KPI profiles is where users can group any number of key performance indicators that satisfy their criteria for monitoring a device. Each group selection from the left part will display the associated KPIs on the right. The user has the option here to enable alerting if they wish to receive notifications on their dashboard. Otherwise, the metrics are collected for statistical purposes only. Creation of new profiles is at the core of Health Insights, as it enables users to combine their KPIs of choice and fulfill their monitoring needs. Health Insights can also present users with KPI recommendations based on a device type. The user can select any device of interest, and Health Insights will display the appropriate KPIs for that type. Also, from the New Profiles menu, a user can select whether they'd like to forward the metrics that will be collected by the profile to an external system for additional processing or long-term storage. Affecting monitoring is achieved by enabling a KPI profile under the Enable/Disable KPI Profiles menu. Users begin with first selecting their device or devices of interest, then proceed to selecting the profiles needed. They then have the option to review their selection and finally complete the task with enabling. Disabling monitoring is the reversible action. We first start by selecting the device, then select the profiles we wish to stop collecting metrics for, and proceed to disabling. Under the Network Devices menu, we can view the number of devices that are currently associated with this CrossWorks network automation system. The display offers details about the devices' types, device names, IP addresses, and various states. Note that currently, CrossWorks has knowledge only of 7 devices, with none of them named XR1. Let's now log into the NSO system. We will begin by exploring the Device Manager. Note here the presence of a device named XR1. This device has been recently added to NSO and is a greenfield device with minimum configuration. Note also the 2 terminals to the right side of the screen. These will be used to confirm that service configurations are being affected on the devices and CrossWorks. We navigate to the configuration editor. From here, we will explore our NSO service that will initially onboard the device onto CrossWorks Network Automation and then it will configure health insights to start monitoring. The service model stores the needed information regarding known Crossworks deployments, shown here as instances. The information will allow NSO to communicate with the target Crossworks setup. We start by adding a new service. Here we are associating device XR1 with our Crossworks instance named dcloud. Let's instruct the service to apply day one configurations to the device, as it is a greenfield device. We will select a data collector and the KPI profile to use. For the purpose of this demo, we won't immediately enable monitoring, just to demonstrate what happens in Crossworks. We commit our service and notice in our XR1 device terminal to the right that the service's day one configurations are being applied by NSO. Back in the Crossworks home dashboard, we can now see that a new device of type unknown is being reported. We now have a total of 8 devices instead of 7 originally. As we navigate to the Network Devices menu, we can confirm the new device is indeed our XR1, but we can see that it is in an unknown state and an erroneous state. Let's check under Performance Alerts menu. Here we can see that the device is not yet present, i.e. there's no monitoring for XR1 in place yet. We move back into NSO. We'll go back to our service and we'll enable monitoring for device XR1. As we commit the service, our terminal log to the right will confirm the monitoring request being sent to Health Insights. Once more back into the Crossworks UI, we navigate to Network Devices, where we now can see that the XR1 device is being queried. Let's also confirm with the Performance Alerts dashboard, where we can now see that device XR1 is listed as a monitor device. As time will progress, the system will begin reporting on the profile's associated KPIs. And with this, we conclude our demonstration on how you can enable monitoring for your NSO devices using Crossworks Health Insights.
You can find more resources regarding the demo on Cisco's dcloud platform. The demo is available on the platform for you to interact with it directly. For further information, you can also find more details about the Crossworks automation suite following the links that you see on the slides here. And this concludes our presentation. Thank you.
Thank you, Dimitris. Knowing the health of the devices is absolutely a critical capability of automation. But that's not enough. You also need to know how the services are doing. And Farooq Mohammed, also technical marketing engineer, will tell you more about that. So with that, Farooq, the stage is yours.
Thank you, Nicholas. In this session, we are going to talk about health monitoring of NSO services. My name is Farooq Mohammed. I'm in the technical marketing group of Crosswork. So the first question is, should health monitoring be part of the network service lifecycle? And the answer to that is absolutely yes. Now, if you look into the details, for example, in NSO service, when we define NSO service, that NSO service will take care of the entire life cycle of that service. What that means is the create, read, update and delete. Now, if we explore the creation is basically we want to provision the network onto the endpoints of that service. Now, when that is done, the work doesn't end there. It's because the provisioning may be complete and it's been verified that that's the case, but the operationalization of that service is as important as provisioning. And for us to measure how the service is performing, we need to make sure that we are collecting the right set of APIs. And if we are not collecting the right set of APIs, then the service may not be working as defined by the SLAs. So it is important and critical that the monitoring of that network service is done from day one. Similarly, when we update that service, update means either we are adding new endpoints to the service or we are adding additional configuration or deleting configuration. When we update that service, if the KPIs are not updated, then we might be missing some critical portions which will relate to the performance of the service or even the degradation of that service, which we have to monitor. Similarly, for deletion of the service, when we delete a service, it's ideally we would want to remove the KPIs that are not relevant to that service, because we don't want any additional streaming information coming into the system. It's always the right amount of information is what's needed. Now, looking at all these aspects, it is very critical that we monitor the service based on the life cycle of that service. So, but how is the health monitoring done today? Now, and what are its drawbacks, if any, right? So we use NSO and for the orchestration, and it works perfectly well for the entire life cycle of service. But when it comes to the health monitoring of that, it's usually a different process, and it's not in combination with the orchestration or the provisioning of that service. So what that means is that we are not monitoring the network or the network services from day one, where we are losing critical information about the performance of that service. Now, usually what happens is that after the network services have been provisioned, at some point in time, maybe days, weeks, or sometimes months, that the network monitoring aspect comes into the picture. What that means is we define the set of KPIs for the services, but it's not for each and every service. It is for the snapshot of what the network configuration is at that point. So we build those KPIs, and those KPIs are provisioned. Usually at this point, those KPIs are not provisioned using NSO service. They are either manually provisioned or there are some hard-coded scripts. So it's not automation, although some may argue that scripts is automation, but in the modern day of network orchestrators, I would think that the scripts are one notch above manual operations, but nowhere can we sort of classify in the modern day as automation. Now, because the NSO's provisioning of the NSO services and network monitoring are two disjoint operations, they're not synchronized. And what this means is that there's a chance that we are not monitoring the right KPIs, and we're definitely not monitoring the right KPIs at the right time. And which adds to the complexity, because this could lead to degradation of services or outages, which we may not be aware of. And when new services are being added or updated, the network monitoring is not drawn in sync. So what happens is that it will increase the number of issues possibly in the network. And also the very fact that it's done manually or using scripts, that means there is a need for extra resources, be it manpower or maintenance of that scripts. And all the additional resources adds up to increased operational expenses. So now that we have understood the way health monitoring is done today and its drawbacks, now let's explore what happens if we integrate health monitoring with NSO as a tightly coupled operation and encompassing the lifecycle of a network service. What happens is that for any provisioning, whether it's greenfield or a brownfield, any provisioning of an NSO service, if it is in sync with the health monitoring, then we have the right set of KPIs that are enabled for the NSO service. And if the service is updated, then the health monitoring aspect will also update the set of KPIs. Similarly, for deletion, it will delete the KPIs which are not relevant. This way, we are always in sync, which means the right set of KPIs are concurrent every single time. And the possibility of missing any KPIs basically is minimized. The additional operation and the resources that are required for monitoring, that also is reduced, is almost completely eliminated, because you do not need extra people to do that. You do not need any manual configuration, and also you do not need scripts. So the maintenance aspect goes away. So how is this health monitoring tied to the NSO service? Because you define an NSO service independent of health monitoring. So because NSO is a platform, we could define a health monitoring NSO service. Let's name it, enable KPI service. If we run this enable KPI service each and every time along with the NSO service, be it for creation, update, or deletes, then we can synchronize health monitoring with the NSO service. So how is this done? So what are the applications that are required for having this effect? Now, this is done using Crosswork applications and NSO. Crosswork is an end-to-end network automation suite of applications, which is flexible, and we can extend it based on the user's requirements. And it's programmable in the sense that each and everything that one can do on the Crosswork UI, there is an API associated with that. And it allows for horizontal scaling, which means it's easy for scaling as and when the load for the Crosswork increases. So let's go over a very high-level overview of what a Crosswork network controller is. It's got a suite of applications, each one for a specific domain. And for our use case of automating health monitoring, there are four main applications. One is Health Insights, Change Automation, NSO, and Crosswork Data Gateway. Let's have a look at each of these in slightly more detail. Crosswork Data Gateway. Crosswork Data Gateway is part of the Crosswork infrastructure. It's essentially a gateway for the network or any other external applications that sends data into Crosswork. So this is sort of the main funnel where the data comes into. It's multi-vendor and supports multiple protocols, like the traditional ones such as SNMP, syslogs, and also for the telemetry such as MDT and GNMI. Now, the Crosswork Data Gateway is designed so that it can scale horizontally depending on the data load. Health Insights. Health Insights, the word Health Insights is used in tandem with Change Automation because they go hand in hand. Change Automation, Health Insights is the one which will define where you can define the KPIs and enable it on the endpoints of the NSO service. And Change Automation is an abstraction of the NSO service, or it's basically a workflow engine which is specifically designed for NSO services so that it can stitch multiple NSO services together to perform a desired outcome. To change automation, an NSO service is mapped to a play, and we can aggregate multiple plays. And these multiple plays are aggregated in a playbook. And you can define the sequence of plays within that playbook. It supports closed loop automation in the sense that if there are any alerts after based on the KPIs, these alerts can then be propagated to an external AI ops system or alert management system. And if that supports remediation, then it can easily be obtained for a closed loop automation. KPIs, so Health Insights has a list of stock KPIs. These are the most commonly used KPIs that we have seen, but with the flexibility that if there are other KPIs which the customers want, then it's easy to create the own KPIs. And so the combination of using change automation to drive NSO services, along with the combination of enabling the KPIs on the NSO services, is what we want to achieve for automated network monitoring. What are the basic functions of Health Insights? It's got a recommendation engine. What that means is that any network that we see has got multiple devices of different versions, and each version has its own set of KPIs because they may be present in certain releases and may not be present in certain releases. The recommendation engine allows you to get the list of the KPIs that are possible for a given device for a specific release. The zero-touch telemetry is where it's possible to enable a set of KPIs. These KPIs are bundled together under a KPI profile. And then by selecting the device, it's possible to provision those KPIs with a single touch almost, once the KPIs have been defined. The Health Insights itself is not an alert management system. So the alerts have to be forwarded on to an external application, but it provides the facility to easily forward those alerts to an external application. It allows for closed loop remediation if the external application has the facility to call any of the playbooks indirectly, which means the NSO services, to fix the issues that are there. The out-of-box KPIs are the list of commonly used KPIs that we have seen in the field over time. To enable some of the KPIs which are not part of the commonly used KPIs, there is a custom wizard with pretty much in a few clicks, you could add the KPIs of one's choice. So when we define KPIs, we need to specify the thresholds. So Health Insights provides two different thresholds. One is statistical threshold, such as standard deviation, mean, and the other one is a two-level threshold, where you could specify two values, for example, say warning and critical, or major and critical, or the combination of those. So it allows the flexibility based on these customer-specific use cases. This is just a snapshot of the UI for the Health Insights, which shows the alerts at different levels. And it also shows the one in the, say, if you can see that, it's called critical, which means a specific threshold was breached for that KPI. In this case, it's CPU utilization, and hence it resulted in a critical alert. And this critical alert can then be forwarded to an external AI ops system. Change automation. So change automation is a workflow engine, but it's not a workflow engine in the traditional sense. It's a workflow engine specifically for NSO services only. And all the functionality of the change automation is basically we could consider that as an exposed functionality of NSO. It's nothing that it's different from NSO's the way NSO provisions or orchestrates things. Now, change automation has a concept of a playbook, and the playbook has plays. Each play corresponds to an NSO service. If you look at a typical provisioning scenario in a NOC, right? So it's basically before you provision anything, you need to do a pre-check. And then in a maintenance phase is where you actually change the configuration of the network. And once the configuration is changed, then you do some post checks to verify that the configuration is as expected. And if there are any issues with that, then ideal scenario is where you sort of roll back. And the rollback functionality is pretty much exactly the same thing as NSO. It's borrowed from NSO itself. But apart from that, there is another one called as, which is part of the change automation, is called continuous checks. This is while and the provisioning or the change operations take time. It could be minutes, hours. Now, we want to make sure that while the changes are being done, the other services are working as expected. That's where the continuous checks come in, where it's running in the background while from the pre-check phase to the post-check phase to ensure that certain critical services are always running, so that when you come to the post-check, there are no services which are disrupted, which were already running before. So how is this done? Now, this is a high-level overview of the flow. Now, the NSO services are mapped to place here, in this case, NSO Health Monitoring Service, which is the enabled KPI service, and the NSO network service. That's the actual NSO service we want to provision. So once the NSO service is provisioned, we get the feedback saying, yes, it's done. Then the Crosswork change automation basically calls Crosswork Health Insights and says, automatically detect all the KPIs that are relevant for the NSO service that's been deployed, create a KPI profile and the KPIs within that, and set the thresholds for each of those KPIs, and then let me know. So once that is done, Crosswork Health Insights then tells change automation, yes, the KPI profile has been created, and can you enable these KPI profiles on the endpoints of the previously configured NSO service? At this point, Crosswork change automation then turns around and tells NSO to enable the KPIs on the endpoints of the NSO service, after which all the KPIs are streamed into Crosswork Health Insights. And if there are any situations which will result in errors, then the Crosswork Health Insights will create those alerts, and those alerts can be pushed into the external AIOps systems. So this is sort of one level deeper into the workflow of what we just saw in the previous slide. The portion where we need to we can concentrate here is in the NSO, where how does the enable KPI profile get the information of how to automatically generate the KPIs? The way it is done is the inputs to the enable KPI profile are the name of the NSO service. In this case, we have taken an specific example of L3 VPN. Suppose we deploy an L3 VPN NSO service and it's successful. And then the enable KPI profile, the inputs are the path to the L3 VPN and the endpoints. With the path, the enable KPI profile can look into the configuration of the L3 VPN and then identify the objects, network objects, such as ports, interfaces, ACLs, BGP, ISIs, you name it, which is part of the L3 VPN configuration, and then get the associated KPIs that are relevant for that. Once it gets those KPIs, it then tells Crosswork Health Insights to provision those KPIs in the KPI profile. So that's how we tie in automatically the enabling of, first of all, detecting the KPIs for that service and auto enabling that the KPIs for that service. So that sort of brings us to the end of this presentation. So there is a dcloud demo which walks you through each one of these steps, especially for the specific example that we saw for L3 VPN, and it will automatically configure the KPIs for that. There's also a blog post which shows you all the details as to how it is done. And if you need any information on the Crosswork network automation portfolio or the suite of applications, this link will take you there. Thank you for your time, and back to you, Nicholas. Thanks.
Thank you, Farouk. It was interesting to see how you have mapped the KPIs to playbooks and how you can let them drive remediation through NSO. It's really easy to see how you can save operational efficiency by doing that. Now we will switch gear to learn more about how you can monitor BGP traffic and how you can optimize that using Crosswork Cloud. So with that, over to you, Wei and Dan.
Thanks, Nicholas. We're very excited to talk to you about what we've built for BGP optimization, and this is something that utilizes both NSO as well as cloud scale traffic analytics. Before we get into this, let's look at something pretty obvious. If you're like a lot of our customers, one of the biggest challenges you have is managing the policy around your peering. And what we often find is that customers often encounter sources of congestion. Likewise, the traffic patterns can rapidly change. And in many cases, this is built by over-the-top applications that automatically rebalance and steer loads from one location to another. And the real challenge here is that the only way for you as a customer to really deal with this is first to have excellent visibility of the actual traffic flows at your peering facilities, but also how do you actually craft the policies to affect the traffic peering? A lot of people actually say that there is no such thing as BGP traffic engineering. It's really BGP traffic nudging. So what we're really talking about here is a solution that we built to actually help solve this problem for our customers. What you normally find is that's a highly manual operation, and we've built something that can support all of our customers and your customers and be able to do this with closed loop automation. We've added the visibility by using cloud scale traffic analytics, and we've also used and leveraged NSO to control the changes to BGP policy. And most importantly, we brought this together in a closed loop solution that automatically handles not only the visibility, but the triggers and also the action to update that BGP policy. So let's talk about what we're going to cover today. We're going to look at how we built a combined solution from multiple components to deliver this outcome for the customers. We're also going to look at how this can become a new type of dynamic closed loop automation for BGP peering. And we'll go through a little bit about the products that we used, how the solution works, and Wei's going to show you a demo of what it looks like. But first, a little background. How did we get here? We were working with a large mobile operator in the Middle East, and one of their challenges is, especially as we're moving towards 5G, there's more and more peering points. It was very difficult to be able to optimize and visualize the traffic at these peering points, and congestion was causing visible impacts on the network. They had a requirement to basically make this not only scalable, but also automated. They had to be able to very quickly react to changes on the network. And most importantly, they had to do this in a way that it didn't require manual intervention from some of their highest level engineers. So what we'll talk to you about today is how we put both a product and service offering together to solve this problem of peering and automation. So how did we get here? The biggest challenge is the solution that does all of this doesn't really exist in the market. So you can't really have effective peering optimization without having very good visibility of the traffic and analytics and understanding of the traffic. And that's something that also has to scale to a large environment. The other part is how do you actually craft those BGP policies and how do you apply these policies? And then finally, really understanding where the actual traffic congestion patterns were and understanding how to craft the policy of how to fix that. This is what's largely a manual operation. So we looked at the available capabilities and we found that through the toolkit that we have, first of all, we can deliver the visibility portion through a new product through Crosswork Cloud. And we'll talk a little bit more about how that works, but this delivers scalable multi-vendor BGP and traffic analysis. Controlling BGP policy is something that we drive through NSO. I'm sure everybody here is very familiar with it. In a way, we'll talk about how we built the solution to drive that policy through NSO to affect those rapid changes. And most importantly, we had to build a service to glue these functions together. And it really relies on API integration with Crosswork Cloud, as well as API integration with NSO to drive those configuration changes. And finally, it also has to deliver user experience so that the customer can actually see and understand how these policy changes are affecting their network, and also have control over how that closed loop automation works. So this overall solution is called the SP integration service. We'll talk more about this at a high level, but what you'll see here is multiple API integrations as well as a UI that helps you drive the changes to traffic policy. And as a user, you get not only the visibility through cloud, but also the ability to control how these actions are taken by the network. So first, let's talk about the cloud scale visibility. This is delivered through a Cisco solution called Traffic Analysis. This is part of Crosswork Cloud. This is a software as a service solution. And what this gives you is two things. It's the ability to visualize traffic flows at your edge points. It also helps you understand what's contributing to those traffic flows. And we can break this down by prefixes or also by individual ASNs. And it really helps you get a much better idea of understanding which BGP prefixes are contributing to the congestion on the network. Now, this works at cloud scale. It does leverage local collection using the data gateway, but more importantly, all of the routing and also the API that we're communicating with is delivered through the cloud service. This aggregates information from NetFlow, it takes BGP information and also SNMP to understand traffic demands, and it puts this together into a single view and a single format that SPIS can act upon to help scale up this environment. Now, traffic analysis is something that does give broad visibility. It does have multiple use cases in terms of understanding the traffic flows and can even do things like suggesting updates to peer prospecting and routing policy, as well as understanding optimization. And these are some of the capabilities that are delivered directly through SPIS. So one of the unique capabilities of this is leveraging the cloud service to deliver a common API. And what this allows you to do is have a single scalable point of control for visibility, but now a persistent API that can always be used to query the information and understand what those traffic flows and what those congestion points do. Now, the next part is where we get into the really interesting portion of automation, and this is what Wei is going to help us understand. Wei, can you tell us a little bit more about how we're using NSO and how SPIS is providing the glue for these solutions?
Thanks, Dan, for the introduction. Now, let's talk about NSO actions, which is a key part of the automation. For this particular solution, we provide a unified operational portal for the end user to have a better experience in terms of influence the action, as well as driving configurations in terms of when they want to pull the data, and as well as whether they want to do a closed loop or not. Because sometimes the user is not ready to fully take a closed loop action. They want to do a wizard approach. Basically, they can see from the UI what actions will be taken and so that is why we have a portal which is hide NSO action. In the meantime, allow user to input their preferences to the action itself. Okay, here are the function packs we developed in order to achieve those actions. One is right before the action is taken, we do a final utilization check actually on the interfaces through NSO rather than through the Crosswork Cloud because of the real-time requirements of this action. That's why we have a discover utilization interface function pack needs to be deployed. The other one are the features through the NSO to support types of actions. One is add a BGP prefix, delete the BGP prefix, and also same thing has to be done for different peering types, private peering, public peering, as well as delete, add different actions to that. Like I said, closed loop is a good buzzword, but sometimes initially the customer may or may not be able to trust the system enough to do the fully closed loop action. That's why we give them a checkpoint in the configuration to see whether they want the system to do a real closed loop or with the user interaction through a wizard presented in the UI. So let's go through the details of how we achieve the goals that we just described earlier. One is, first, we need to understand the traffic congestion and what are the prefixes that carries the traffic that contributed to those congestion. Through the Crosswalk Cloud, it presents that information with APIs. One is the traffic statistics on the interface level, which is pulled from the NSO, from the on-prem Crosswalk Cloud CDG deployment. The second is the per prefix traffic for an interface on a device that is also pulled by deployed on the cloud from the NetFlow information. So here the APIs in green is what we have leveraged for this application that we're showing. This slide just shows you some of the control that we provide portal so that user can influence the action in terms of when and how to take it. This talks about when. This allows you to configure the utilization threshold and low for different types of interface. So you can make sure that traffic balance is controlled within a range. Too high or too low, both are not very desirable. Nobody wants to waste the bandwidth as well. So this allows you to control that and have a better user experience. This gives you in terms of how you want to influence the actual NSO action. You can see from here, this gives you input in terms of where is the node and what are the peering providers of that node, as well as the prefixes in terms of category and priorities. In the reality, all providers only want to move the traffic first from the lower priority customers, not the VIPs. Nobody wants to touch the VIP traffic, which potentially can cause some interruptions. So this is where the interface allows your customer to tell the input into how we were going to calculate which prefix to move, as well as what target traffic interface to move it to. The third part of this configuration is the input of the route policies. This gives the ability for the NSO to take a metadata configurable approach to dynamically be able to search where those prefixes are in order to move them. The third configuration that user can do is the admin, which is in terms of how often you want to trigger the action, whether if the threshold is cross the threshold one time or 3 times, because one time may or may not reflect the reality because it could be just a quick spark and then it go back to normal. So this gives you a control of how you want to trigger the action. And I did not show you a button on closed loop. So there is a button you can check. If you click on that button, say closed loop, literally you're not going to be able to see the wizard. It will just automatically runs on its own and send you the result for before and after the change is finished. So let's show you a demo. So in this screen, you can see this is a unified portal I just described. And the data here you see is pulled from crosswalk traffic analysis through the API integration. The utilization is from the statistic APIs that traffic analysis provide. The prefix utilization is from the traffic per prefix, per interface, per device APIs that the Crosswalk Cloud provides. And the polling cycle currently we configured is every 5 minutes. So you can see we have set utilization threshold, which is 10. That's why this is showed as red because it's above the 10, and action button is showing up. So if you click on that, because I did not set as closed loop, and you will see this wizard. If I set closed loop, you will not see this wizard. So you can see here is what is the target interface traffic that can be moved. As I said before, these are based on the user input you provided in the configuration. And based on that, we select the traffic that can be moved from the interface. The congestion, you can see from here, it is down from 11 to below 11%. And you can make some changes as well. That's the benefit of the wizard. Then you click select target links. This will calculate based on your input in terms of where the node is located, which provider you are, this node is appearing, and use that input, we decide where to move this traffic, because we want to move the traffic within the same provider interfaces as long as there is such free capacity to take that. Otherwise, we will be moving to a different location, a different provider interface. Those algorithms are implemented behind the scenes, which you can influence, a user can influence through the UI input. Once I click this, it actually triggers an NSO action. You can see it tells you what packages, APIs we're calling. The add transit is something that I just showed in the previous slides, that one of the function pack that we have implemented. So this will take some time. This actually is performing the action on device. This will take some time. And after that, it will also does a RR validation, meaning if the traffic policy, a BGP policy actually taking effect or not from the public routing database. If it is, then we will remove the prefix from the original interfaces and keep it only in the target interface. If this validation comes back negative, then we'll keep the original prefix to the original interface so that we make sure there's no interruption at all for the traffic. So that's the idea behind the whole logic. Okay, this will take some time. After this is completed, it will say complete. And 5 minutes later, in another cycle, you will see the utilization instead of red will become because the congestion is removed. Okay, that's the demo. And then would you like to conclude?
Thanks for the view into how SPIS actually works in a live environment way. That's pretty exciting. I think as we wrap here, our takeaway is that we've seen that this is something that almost every service provider and also large enterprises, this is an area where they need a lot of help, where there's not a lot of tools. We can show how this can very directly reduce OpEx and add visibility and also closed loop automation. And most importantly, everything that we showed you here is 100% multi-vendor. It's coming from Cisco, but there's absolutely no requirement that any of the underlying products are actually Cisco devices. That's one of the strengths of both the cloud solution and NSO, is the ability to drive this multi-vendor. So we think that this is an exciting offer for the marketplace, and this is something that is also a great use of the tools that we have here at Cisco. So with that, really appreciate the opportunity. Thanks a lot, Nicholas, and back to you.
Well, thank you, Wei and Dan. That was our last session today. With that, I'd like to thank you for joining us and engaging with us during these 2 days. Just a short recap of what we have been talking about today. So we started with talking about the strategic direction. We talked about how we with Crosswalk Automation Suite drive higher level abstraction to make your job easier. We also talked about the importance of monitoring devices and monitoring the entire service life cycle, as well as BGP peering traffic using our Crosswork Cloud product. So with that, I only have one final reminder for you, and that is to take the survey. We do love your feedback, and it helps us improve. Also stay tuned for the recordings. You will find them on the Event Hub and then finally on our YouTube channel. If you have signed up to the workshops, I'll see you over there. If not, have a great day and thanks a lot.